under fractions, ladies and gentlemen. We've already done this, but it's a good review. Today we talk about dividing them. And if you look in your notes under dividing fractions, we already wrote down the handy-dandy phrase that pays, which is, how do you divide by a fraction? You should have written in big words there, Julia. Exactly. Multiply by reciprocal, which in the generic phrase of 6th grade, we could also just say, I like to say, flip and multiply. It's a simpler little way to say it. Now the problem with that is, sometimes it's hard to recognize when you divide by fractions. And for that reason, we shall write down this example problem. How many 1/2 are in 3/4? How many 1/2 are in 3/4? Now this is one of those ones that you can beat yourself up thinking about this. And some of you actually are mathematical enough, you probably could get the answer to this just by looking at it and thinking about that. But let me suggest to you strongly that since fractions usually confuse people, in order to figure out what you do, switch the fractions with whole numbers and see what you would do if it was a whole number. For example, if I asked you how many 2's are in 8, how many 2's are in 8? Most of you pop up and say, well, that's easy. That is what, Nathan? 4. How did you do that? What type of problem is that? It's division. You took 8 and divided it by 2. Well, because it's fractions, you'll do the same thing. You'll take, it's not 8, but 3/4, and you'll divide it by 1/2. There's the problem. And now that you know how to divide by a fraction, what am I going to do here? Instead of dividing by 1/2, I'm going to flip and multiply. And it's always the second one. Do not flip the first one. It's always that second one. So it's 3/4 times 2/1, which doesn't work out nicely, but it's okay. It's 6/4, which is 3/2, which is 1 1/2. There are 1 1/2 1/2s and 3/4, which again doesn't, most of us don't spend our time thinking that way, but that works. Now the question, you know, related to money, maybe it works. How much is $1/2 dollar? 50 cents, right? And how much is 3/4 dollar? 75 cents. If I asked you how many 50 cents could you take out of 75 cents, well, again, not the easiest problem, but you can take at least one 50-cent out, right? And you're left with how many cents? And 25 cents is half of 50 cents. So 1 1/2 is the answer to that. Not that you should change it to money, but I'm just showing you that it actually does work in the real world. So anytime you see a problem like this, try to think of a whole number. If you put whole numbers in there to think of what process you do, then it'll work for the rest of your life, people, by the way. Let's see if there's another one. Is there another one? How about this one? How many 1/2s are in 3/8? I'll give you a chance to do that one. How many 1/2s in 3/8? God bless you. Give you 30 seconds. It's the same exact type of problem we just did. You should be able to figure that one out. Did we get an answer? Maggie, did you get an answer?
Yeah.
What'd you come up with, Maggie?
6/8.
Well, 6/8 could be reduced to what? If that in fact is the answer. 6/8 is what? Reduce it, cut them both in half.
3/4.
3/4, yeah. And again, if you don't know, think of something. How many 3's are in 12? Well, the answer to that is 4, because you took 12 and divided it by 3. 12 divided by 3, but it's not 12, it's actually 3/8 divided by 1/2. So you flip and multiply by 1/2, it's multiplying by 2 over 1, and that's what made you got 6/8, but you gotta make sure you reduce that to 3/4. Are you good with that? And then, also under fractions, one new topic here is write this word down, reducing. The other new kind of thing they give you is this. They'll ask you to reduce something that looks like this. 2 times 2 times 3 times 5 over 2 times 2 times 5. First things first, if you see a problem that looks like this in the book, much to your chagrin, the first thing you're going to do is, Max?
Draw it out.
I'll just write that down. You will write this exactly as it is in the book. Now, the question you have is, how do I reduce this? The question you have is, how do I reduce this?
How do I reduce this?
Only one person has that
Mr. Hahn,
question.
how do I reduce
That's a great
this?
question. How do you reduce this? Well, the deal is with this, is this. You just simply cross off identical tops with bottoms 1 for 1. Which you'll go, what? That's a lot of words for something that's pretty simple. And then maybe I'll try to get you the gist of that. That means this, ladies and gentlemen. If you see the same number on top as on bottom, you can just cross it off. If I have a 2 on top, it'll cross off with the 2 on the bottom, and it goes away. If I have a second 2 on top, it'll cross off with the second 2 on the bottom. It goes away. I don't have any 3's on the bottom, so this 3 is going to stay, but this 5 and this 5 cross off because they're identical. And guess what I'm left with? The number 3. What they are trying to get you to see is this. Okay? If I multiply this out, does anybody know what 4 times 15 is? 60, right? And 4 times 5 is 20. This and this are the same thing. And they're asking you, if you reduce this, what would it look like? Well, I could cut them both in half and get 30 over 10. That would be like this. There's those two. I could cut them both in half again and get 15 over 5, which is cutting in half again. And then what number goes into both of these? No, not 3, but 5. 5 goes into both of those to give you 3 over 1, which is the answer you got. They're trying to get you to see that when you reduce a fraction, it's really the same as making it. We've primed factorized things. Have you primed factors before? Probably not. Anyways, just remember you cross off 1 for 1. Now, here's what you must note, children. Write this in big 6th grade letters. Note. Everything on the bottom crossed off, right? The 2 crossed off, the 2 crossed off, and the 5 crossed off. Which left me with just the number 3 on top, right? If this were flipped over and it looked like this, 2 times 2 on top, and the 2 times 2 times 3 times 5 on the bottom, the 2's would cross off, the 2's would cross off, the 5's would cross off, and I'm left with the 3 on the bottom. Ladies and gentlemen, this is a deep breath moment for you. If you are left with just a number on the bottom, that number has to stay on the bottom, and you must put a 1 on top. If all of the top numbers cross off, there still remains a 1 on top. Now that's really the same case for this one. If all the bottom numbers cross off, there's still a 1 on the bottom. But the 3 over 1 is the same thing as 3, so we don't need the 1. So in this case, you can get rid of the 1 because it's not needed, but in this case, if it's the top that crosses off, you must keep that 1 there, otherwise you will get the wrong answer. And your number one goal in life, Max, should be not to get wrong answers, right?
Mhm.
Now let me give you one more, see if you can do this one. What do you get if you have this? 2 2s, 2 3s, and a 5. 2 2s, 2 3s, and a 5, and that is all over, that's all multiplication. 2 2s, a 3, and 2 5s. 2 2s, a 3, and 2 5s. If the direction said to reduce this, what would you get if all of that reduced? Wah, 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 wah.
Is that a 22?
2 times 2. 2 times 2 times 2 times 5 times 5. Zach, what happens? What crosses all off? You're left with? Right, because, let me get the right color. These will cross off, these will cross off, these will cross off, and 5 and 5 will cross off, leaving you with just 5. Is everybody relatively good with that?